Hello students, welcome to math session of SS2. I am Mr. Femi Lawal, a mathematics teacher, and I will be taking you on linear inequalities. Before I proceed, let's look at the few objectives we have set out to achieve. By the end of this lesson, you're expected to be able to define inequality, solve problems on inequalities, and represent inequalities on number lines. Then, what is inequality? Inequality can be defined as a relationship between two numbers such as 4 and 2, quantities such as a bag of rice and a plate of rice, and expressions such as x minus 2, y minus 4. What are we saying? Inequalities is a relationship between two numbers, quantities, or expressions that are not equal. For instance, I have these two markers. Of course, we can all see that they are not of the same length. Fine. Look at these two containers. Definitely they are not of the same size. The same way we look at watermelon and orange. Definitely one will be bigger than the other. Now, when we are talking about inequalities, we have some symbols we use and we need to know. Inequality symbols. We have a less than, which means that the number in question is not up to, not up to. Then we have greater than. These two I tag exclusion. Exclusion. In what sense? If we are giving x less than 2, what we are saying is that excluding these two, all numbers below 2, that is what this inequality represents. And if I'm to define it, I have from where? 1 down. You have from 1, 0, minus 1, minus 2, and so on. And so on. Then, this is saying greater, meaning that if we are giving x greater than 7, we mean all the numbers above 7, excluding 7. So we have 8, 9, 10, 11, and so on. So that's why I call these two exclusion. Now, if I now combine any of these two with the equal sign, I have less than or equal to. That shows that I have less than or equal to, or greater than or equal to. I tag this to inclusion. Inclusion. The two as inclusion. In what sense? If this is saying less than or equal to, and we are giving x less than or equal to 1 minus 1, what we are saying here is all the numbers below 1 and including 1, That is what this sign means, including, oh sorry, -1, including -1. So then we have all these numbers below. So you have from -1, 0, sorry, -2, -3, and so on, coming down to the negative axis. Then this is saying greater than or equal to. Therefore, we have, if we are given x greater than or equal to -5, we mean all the numbers above 5. Then because of this sign, we now say including all the numbers above -5, including -5. So we start from -5, -5, -4, -3, and so on. So these are the symbols we use here. Now it will be very easy for us to differentiate between the less than and the greater than using the left and the right elbows. The left will give us less than, while the right will give us the greater than. So greater than, less than, greater than, less than. All right, we are going to solve inequalities in one variable, and the principles we use in solving linear inequalities, they are similar to that we use in solving linear equation. Now, the only exception is where you have a negative coefficient, you have to divide both sides by a negative coefficient. Let's look at these examples. Solve the following inequalities. 1, we have 2x plus 7 less than 13. The first thing we need to do here is to collect the like terms. Just the same way we solve a linear equation. Assuming this is given in this form, 2x in an equation form, 13. This is not the same thing as this. So if I'm solving this, I have 2x equal to 13 minus 7. I'm moving this 7 to the other side. The same thing I'm doing here, collecting the like terms. 2x less than 13 minus 7. We are saying the same thing. The only difference is that this is an inequality and this is an equation. While this is giving you 2x equal to 6, this is also giving you 2x less than 6. You are dividing through here by 2, and your x is giving you 3. When you divide through here by 2, your x will give you less than 3. X will be less than 3. 2. 5 minus 2x less than 9. Yeah, when you have this, you are also going to collect the like terms. Now, I want to rewrite this. This is an inequality. I want to write it in an equation form. Minus 2x equals to 9. Now, I'm to collect the like terms. Look at it. I'm leaving my coefficient on this left-hand side. I'm moving the constant to the right-hand side. The positive constant will become negative when it crosses the equal sign. Then, when you do the same here, you have negative 2x less than 9 minus 5, because we are moving the 5, positive 5, to the right-hand side from the left-hand side. So what we are trying to explain here is that we follow the same principle for inequality and their equations. Now, at this point you have negative 2x equal to 4. 9 minus 5 will give us 4. And here you have the same thing, but instead of equal sign, it will be inequality sign. So let's go ahead. Here, to conclude this, you have to divide through by the negative coefficient, which is minus 2. Negative 2. You have negative 2 over negative 2 equal to 4 over negative 2, and your result will be negative 2. But when it comes to this, you divide through as well. Divide through by negative 2, negative 2x over negative 2 less than 4 over negative 2. When you do that here, this sign, the symbol, will change to its opposite. The opposite of less than is a greater than. So that is x greater than negative 2 means that all the numbers above negative 2, excluding 2. So in that, we can have a set of what? Negative 1, 0, because it says greater than negative. So you have 1, 2, and so on. That's the difference in the solving. When you solve inequalities, you solve it the same way you solve an equation. But when it comes to dividing through by a negative coefficient, the equal sign will not change, but the inequalities will change. Now let's go to the third one. The third question there is giving us 2 into x minus 1 less than or equal to 6. Yes, there are two ways I can solve this now. I can decide to reduce the value by dividing through by 2. And the reason is that 2 is a common factor of x and minus 1. So reducing this will give me x minus 1 less than or equal to 3. So if you move this negative 1 to the right hand side, you have x less than or equal to 3 plus 1, and my x is less than or equal to 4. The sign is not changing because I am not doing a division. I'm not dividing through by negative division. Now, if I don't want to follow this process, I can still expand. I can still open the bracket. That is, multiply x by 2, so you have 2x. Multiply 2 by 1, you have minus 2, less than or equal to 6. So again, you need to collect the like terms, like we did here. You have 2x less than or equal to 6 plus 2. Because we have moved the negative 2 from the left hand side to the right hand side. It's now positive. So you have 2x less than or equal to 8. In this case now you have to divide. You have to divide both sides. Divide both sides by 2. And you have 2x over 2 less than or equal to 8 over 2. So my 8 is less than or equal to 4. So I have the same result as this. Number 4. I have x minus 3 over 2 less than minus 5. And as it is now, on this left hand side, I have a fractional expression. I can still solve this in two ways. It's either I am clearing the fraction, clear the fraction. You say cross multiplication. A language is said to be wrong. So we use clearing of fraction, clearing of fraction. So if I'm going to do that, I'll just have this over 1. So you have 1 times x minus 3 less than 2 into minus 5. When you open this, you have x minus 3 less than minus 10. Collect the like terms. So you have x less than minus 10 plus 3, because this negative 3 is moving from the left hand side to the right hand side. And my x will be less than minus 7. That's the solution for that. If I don't want to go with this method, I can still solve it in another way. Over 2 less than minus 5. I can just find since I have a fraction here, I can just find the LCM across board. Of course, this one has a denominator of 1. So the LCM of 2 and 1 is 2. Then I'll use the 2 to multiply each of the terms. Our target is to eliminate the denominator, 2. So you have 2 times x minus 3 over 2. Remember to close this, x minus 3. Then less than 2 times minus 5 over 1, where these 2 LCM will delete the denominator 2. So you have 1, and that is x minus 3 less than minus 10. Collect the like terms. So you have x less than minus 10 plus 3, and your x is less than negative 7. Number 5. 3. 1 over 4 into x minus 3 less than x over 3. Now, we observe here that we have fractions on both sides, and we have denominators 4 and 3. So all we need to do is to get the LCM. The LCM of 4 and 3 is 12. So I will use this 12 to multiply the terms. In fact, this is one term now, and this is another. So you have 12 times 1 over 4 into x minus 3 less than 12 times x over 3. I don't want to do this, just put it this way. So you have 4 here, 1, 4 in 12, 3. 3 times 1, 3. Then you have x minus 3 less than 3 in 3, 1. 3 in 12, 4. So you have 4 times x, and that is 4x. Then I will open this bracket with 3. 3 times x will give me 3x. 3 times minus 3 will give me minus 9 less than 4x. So I'm going to collect the like terms here. I prefer to have the variable on the left hand side, the unknown on the left hand side. So I'm going to bring this 4x to the left hand side, bring it to the left hand side, and that will give us 3x minus 4x less than, then this constant is moving to the right hand side, and that will give me 9. And 3x minus 4x will give me negative x, that is negative 1x less than 9. Now, it is not appropriate to leave our answer in this form, because the x, the variable, must be positive. So I will either multiply through both sides by negative 1, or I divide through by negative 1. So I will divide through by negative 1. Negative 1. Then as you do this, remember, this sign will get angry and tell this 9, I don't want to be your friend again. Then it will turn to x. So instead of less than, it will now change to greater than negative 9. This question here, if you look at it very well, you discover that we have two inequality signs, less than or equal to, less than. Then there are two ways we can solve this. You either solve directly or you break this into two. So let's solve directly first. You have 3 less than 8 minus 5x, and what we are trying to do is to leave this x at the center. So what I will do is remove this 8, and when you are removing it, you remove it to the left hand side, you also remove it to the right hand side. Therefore you have 3 minus 8 less than or equal to 8 minus 8 will give us 0 there. So you have minus 5x less than 13 minus 8. So this is minus 5 less than or equal to minus 5x less than 5. Now, the x is still not alone. This woman is pregnant. Now, this baby will have to go away. So what we need to do here is to divide through by negative 5. So you have negative 5 over negative 5 less than or equal to negative 5x over negative 5 less than 5 over negative 5. So when we divide through by negative 5, you have 1. This sign will change and this will change, and the reason is that we are dividing through by a negative coefficient. So you have greater than or equal to x greater than negative 1. Now let's look at it if the statement is true. 1 greater than or equal to x greater than minus 1. Yes, 1 is definitely greater than negative 1. So if I want to rewrite this statement now, let's look at this marker. You have whiteboard marker. If I turn it this way, it's upside down now, but it reads marker board white. That shows that if I want to rewrite this, the entire statement will be written from the left and from the right. So you have minus 1, and this is going to change to less than x less than or equal to 1. Then the statement is true. We are true with this solution. Now we are quickly going to look at how this can be represented on a number line. Number lines, there are two symbols we need to take note of. You have the open circle, then we have the closed dot or closed circle. Dot or closed circle. This open circle represents less than, greater than, which we called exclusion. And the closed circle represents less than or equal to, greater than or equal to, which we call inclusion. Let's look at some examples here. We want to represent these inequalities on number lines. And when we have x less than 2, what we are saying on number line is this. This is my 2, but because the statement is saying less than, that is excluding that 2, you need to put an open circle here, and less than is going to the left hand side, less than. So you have x less than 2. This is how we represent this on number line. And what are the numbers in question here? You have 1, 0, minus 1, minus 2, and so on, excluding 2. But we have these numbers on the right hand side, but they are not important. 3, 4, 5, 6, and so on. B, we have x greater than minus 7. We mean if this is minus 7, then, and it is greater in exclusion. Excluding 7, you have numbers from minus 6, minus 5, minus 4, and so on. So 0, 1, 2, 7, 8, 10. But not numbers on this side. It is greater than, you have this one. These numbers are less than minus 7, minus 9, minus 10, and so on. C, x less than or equal to minus 3. What we are saying is this. This one is x greater than minus 7. You have minus 3, arrow. So, since it is saying less than or equal to, then it shows that we have a closed dot, a closed circle. Then less than means it is going leftward. This is x less than or equal to minus 3. And the numbers in question include negative 3. So you have negative 4, negative 5, negative 6, and so on. But not negative 2, negative 1, 0, 1, 2, and so on. So if I ask to write out the set x less than or equal to minus 3, we have minus 3, minus 4, minus 5, minus 6, and so on. Then G, x greater than or equal to 5. What we are saying is this. You have 5. Because it is inclusion, you have a closed circle, and greater after 5 to the right hand side. So you have x greater than or equal to 5. And the numbers are 5, 6, 7, 8, 9, and so on. But not 4, 3, 2, 1, and so on. Then E, minus 2 less than or equal to x less than 4. We have this. Negative 2, 4. And because this is inclusion, including 2, so I will have a closed circle. Excluding 4, you have an open circle. But they are going this way, to the right, to the left. This is the same thing as saying x is greater than or equal to negative 2. That's why it is going this way. And this is saying x is less than 4, and that's why it is coming to the left. Yeah. Now, the last one here, this is saying x is less than or equal to minus 5, comma, x greater than or equal to 2. These two cannot come together, and so is the behavior, their behavior on the line. Let's see. You have this. If I say minus 5, let me put it here. Minus 5 and inclusion, and it says x less than. That shows I'm going to the left hand side. This is x less than or equal to minus 5. Then I'm coming to place 2. You have 2 here, and it is still inclusion. So you have closed dot. And this is saying closed circle. This is saying x is greater than or equal to 2. If it is greater, then I'm moving to the right. So that is the representation. So In this session, we have been able to define inequality, and we have been able to solve some problems, and we have represented some on number lines. We are going to stop here. Before we go, I'm giving you 5 questions to solve and forward to the email below here. fgchcdgclass@gmail.com. Remember to indicate your name, class, subject, and topic. See you next time.